All right, so today we're doing 5.2, ways to prove quadrilaterals are parallelograms. In this chapter, we're trying to get enough information to prove that a quadrilateral is a parallelogram based on the information and criteria in the definition of a parallelogram. So as we know, definition is a four-sided figure with opposite sides parallel. Since we also know that opposite sides of a parallelogram are congruent, we can also say that if that is true, that quadrilateral is also a parallelogram. If we know that one pair of opposite sides is both congruent and parallel, then that four-sided figure is a parallelogram. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. This would be the converse, and they should all sound very similar to the converses of the theorems that you learned in 5.1. And finally, if the diagonals of a quadrilateral bisect each other, then you know that the quadrilateral is a parallelogram. So there are 5 ways to prove that a quadrilateral is a parallelogram. This is also found in your textbook if you wanted to write it down. You need to prove one of these 5 ways. Both pairs of opposite sides parallel, both pairs of opposite sides congruent, both pairs of opposite angles congruent, or one pair of opposite sides are both congruent and parallel. Or you could show that the diagonals of a quadrilateral bisect each other. Any one of these 5 ways would be a perfect way to show that a quadrilateral is a parallelogram. Hit pause right now and determine whether or not these 4 figures have enough information to show that they are parallelograms. For the first one here, we have opposite sides of this 4-sided figure to be congruent. Therefore, we could prove that it is a parallelogram. Over here, it shows that 2 congruent segments are bisected by AC, and AB and CD are also congruent. Unfortunately, the only vertical angles piece that we could prove allows us to say that there's not enough information for this to be a parallelogram. For ABCD, even though we know 130 and 130 are opposite angles to be congruent, there's no way to tell that B and D would be congruent because we don't know anything about their parallel properties. However, over here, we see that opposite alternate interior angles are created by the transversal AC. Therefore, we have a converse of the alternate interior angles theorem to state that CD would be parallel to AB and BC would be parallel to AD, making that figure a quadrilateral, being a parallelogram. Take a second and try to prove, based on the given that triangle RST and triangle PSA are congruent, that somehow you could prove that PART is a parallelogram. Hit pause and do that now. Maybe not in this particular order, but the given information would be first. After that, something like RS and PS, with TS and AS being congruent because of the corresponding parts of congruent triangles. S would then be the midpoint of that, making the diagonals bisecting each other, and therefore PART is a parallelogram. You may have used CPC-TC another way and still proven triangles to be congruent and then use their corresponding parts without proving the diagonals are congruent. You may have used AR and PT to be congruent after CPC-TC or something like that, which is also acceptable. At this time, on your worksheet, please answer questions 1 through 6 and then turn the page over. On the back of your worksheet, you have 2 proofs numbers 14 and 15 that only ask you to number the reasons based on where you think they fit in the proof. For homework, your job is to finish the back side of that worksheet and numbering the proofs at the bottom accordingly. Please finish that for homework.